Okay, so today we're going to learn about reciprocal circular functions. Now, hopefully you've realized that a circular function is what we've been doing. We've been taking a graph, we put a unit circle on it, and then the Greeks put triangles in these unit circles and compared the sides of the triangle formed, and we got these different words: sine, cosine, and tangent. Well, did you ever take the time to wonder, well, how come it's opposite over hypotenuse? How come we didn't do a hypotenuse over opposite? Or how come we didn't do hypotenuse over adjacent? Well, we did. We just didn't teach them to you in 8th grade. And that is the reciprocal. Reciprocal means to flip. So we're going to learn today what is hypotenuse over opposite and hypotenuse over adjacent and adjacent over opposite. They are the reciprocal circular functions. Okay, so this page, you're going to want to pause and copy it all down. All right, so we have here our original function of sine, which was opposite over hypotenuse. Now, if I flip sine, it becomes 1 over sine, and so I'll flip and I get hypotenuse over opposite. 1 over sine is a reciprocal function, and now we call it cosecant. We will explain where this word came from, but just not today. We just want you to be introduced to it, and its abbreviation is CSC. Cosine. When we flip it, we get 1 over cosine, and it's hypotenuse over adjacent because it's flipped, and this is called secant. And its abbreviation is SEC. No, Cooper, that's not the Southeast Conference. It's secant. You can kind of see a little bit going on here, like cosecant and secant. We'll get into that again later on. And then finally, tangent. Tangent over 1 flips to 1 over tangent, so therefore we flip opposite over adjacent, adjacent over opposite, and it's called cotangent. At least that one makes sense. Cotangent. And there's its abbreviation. So make sure you copy this all down. I feel a video quiz on this chart. All right, so let's try and play with all this stuff now. If the terminal side of an angle is in standard position and it intersects the unit circle, it intersects the unit circle. So we've got a unit circle going on here, and here it is right here. And this is the point. So just to give myself a little background, I'm going to come over here and I'm going to go over negative .9, and then I go up 0.7. And since they said it's a unit circle, I know this is a value of 1. Okay, so find all the values of the 6 trigonometric functions. Well, this isn't bad. I got to bring back out of my memory that the x value and the y value in trigonometry, the x value is really the cosine of the angle, and the y value is really the sine of the angle. Oh, how easy is this? The sine of this angle. The sine is the y value. So the sine is 0.7. And the cosine is the x value. So that's negative 0.9. And tangent, tangent was the sine over the cosine. So let me do a little math right here. My sine is 0.7. My cosine is negative 0.9. Okay, move the decimal over to make that 7. Move the decimal over to make that 9. Oh, there's my tangent. Negative 7 over 9. All right, now let's do these new functions. These new functions tell us that they're reciprocals. Really? Why is that erasing? That's odd. There it is, back. So this new function, cosecant. Let me go back to this table. Cosecant is the reciprocal of sine. Oh, so I just flip. 0.7 is really 7 over 10, so cosecant is 10 over 7. Cosine, secant, they're the flip of each other. So if this is negative 0.9, this must be negative 10 over 9. And if this is negative 7 over 9, then the cotangent is the flip of that, negative 9 over 7. Now if you remember, this point was here in the second quadrant before it all got erased. And notice what quadrant it's in? The sine quadrant, the second quadrant. So that means only my sines are positive. Yep, that's positive, so therefore its reciprocal is positive. Everybody else has to be negative, because only sine is allowed to be positive. Pretty good. All right, last question. If point 4, negative 5 is a point on the terminal side of an angle in standard position, it didn't say anything about being on a unit circle. So that means I have to create my unit circle. All right, so negative, all right, so 4. So I'm going to go over 4 and down 5. So there's my triangle. So I went over 4 and down 5. So since this is a unit circle I'm creating, I got to take some time here to do Pythagorean's theorem. So a squared plus b squared equals c squared. 16 plus 25 equals c squared. All right, so that would get us 1141 equals c squared. So c is the square root of 41. Okay, so now let's just do our answers, because there's our angle theta. So sine is opposite over hypotenuse. So negative 5 over radical 41. I have to rationalize that. So that would be negative 5 radical 41 over 41. Cosine, adjacent over hypotenuse. So that's 4 over radical 41. Again, I will rationalize that. 4 radical 41 over 41. Tangent is opposite over adjacent. Excellent. Nothing hard to do there. Now, cosecant. I like writing them this way because I can just match up my reciprocals. Cosecant is the reciprocal, so if I flip that, I get radical 41 over 5, and it's negative. I'll flip this, cosine, to get my secant. Radical 41 over 4. And I will flip my tangent to get my cotangent. Negative 4 over 5. And again, if I look, I'm in the fourth quadrant here. So in the fourth quadrant, only cosine can be positive. So when I look up here, excellent. My cosine is positive, and its reciprocal is positive, and everybody else is negative. Done.